What China has just uncovered on the moon has stunned scientists across the world. Hidden on the far side, a place no human eye had ever seen until recently, lies evidence that could rewrite the future of energy, space exploration, and even life itself. The question is, why does this discovery scare experts as much as it excites them? For decades, the moon seemed irrelevant. After the glory of NASA's Apollo landings and the Soviet lunar missions, our closest neighbor was dismissed as nothing more than a dry, airless rock. Humanity's gaze drifted further, toward Mars, and even the promise of distant exoplanets. But quietly, everything began to change. NASA reignited its ambitions with the Artemis program. SpaceX vowed to carry industries beyond Earth, and then came China, moving slowly, methodically, and with an ambition that is now impossible to ignore. The focus of the space race has shifted once again. Across the world, scientists and governments look upward, not to the red sands of Mars, but back to the silver light of the moon. A place that may not be as barren as we once thought, but instead, a gateway to humanity's future. China's journey to the moon began in the early 2000s, when most of the world still considered it little more than a relic of past glory. In 2007, the mission known as Chang'e-1 was launched. Its task appeared simple, to map the moon in 3 dimensions. But buried within that data came something extraordinary. Scientists confirmed significant traces of helium-3, a rare isotope carried by the solar wind and trapped in the lunar soil. Unlike Earth, where helium-3 is vanishingly rare, the moon holds it in abundance. Enough, some estimate, to power civilization for generations if nuclear fusion becomes a reality. This discovery reframed the moon. No longer just a symbol of exploration, it became a potential reservoir of clean energy, a resource so valuable that entire nations might race to secure it. And from the very beginning, China's ambitions were clear. They were not simply studying craters, they were laying the foundation for the energy economy of the future. China did not stop with mapping. Each mission became a stepping stone, a rehearsal for something greater. In 2010, Chang'e-2 was launched, flying at lower altitudes, capturing images with astonishing precision. For the first time, humanity could see vast craters and hidden valleys in detail that revealed just how alien and how ancient the moon truly is. Then came Chang'e-3 in 2013, a breakthrough moment. For the first time in nearly 4 decades, a spacecraft achieved a soft landing on the lunar surface. Riding down aboard it was the rover known as U2, the Jade Rabbit. Mounted on the lander was something visionary, the first astronomical telescope ever operated from the surface of the moon. Freed from Earth's atmosphere, its ultraviolet eyes peered into the galaxy with unfiltered clarity, giving scientists a taste of what the moon could become. The ultimate observation platform for studying deep space. The rover itself roamed across the lunar soil, carving history into each dusty path it left behind. Every measurement, every grain of regolith it analyzed, was another step toward unraveling the moon's profound mysteries. By now, it was clear. China was not racing toward a single flag-planting moment. It was building capabilities piece by piece, mission by mission. Each success prepared the ground for something bold and far stranger than the world expected. In January 2019, China achieved what no other nation had dared: the first landing on the far side of the moon. The spacecraft Chang'e-4 descended into the vast von Karman crater, carrying with it the rover U-2. This was more than a scientific feat, it was a triumph of ingenuity. The far side of the moon has no direct line of sight to Earth, making communication nearly impossible. To solve this, China positioned a relay satellite, Huiqiao, at a gravitational balance point known as the Earth-Moon L2 Lagrange point. From there, it could bounce signals across space, opening a channel into a world no one had truly explored before. And what awaited was like another planet entirely. Unlike the near side, scarred with vast lava seas, the far side revealed rugged highlands and ancient impact scars, a thicker crust, and terrain that whispered of violent cosmic events billions of years ago. For the first time, humanity was looking directly at a side of the moon that had been hidden for all of history, and it looked nothing like what we thought we knew. The missions that followed began to completely rewrite everything scientists thought they knew about the moon. On the far side, measurements revealed a lunar crust with a very different chemical makeup compared to the near side. Instead of the familiar vast volcanic moriah, here the surface is dominated by ancient rugged highlands and colossal impact craters, scars from cosmic collisions that date back billions of years. This demonstrated that the moon is not a uniform world, but rather a celestial body shaped by dramatically different forces on each side. Then came 2020's breakthrough, the Chang'e 5 mission, which successfully landed, drilled, and returned 1.7 kilograms of pristine lunar samples to Earth, the first new lunar material to arrive since the Soviet Luna 24 mission almost half a century earlier. For scientists, this was akin to opening a sealed time capsule containing clues about the early solar system. Within these precious samples, planetary geologists made an astonishing discovery: a completely new mineral labeled Changeasite-Y, a transparent, crystalline substance only visible under powerful microscopes. What made this mineral extraordinary was its enrichment in helium-3, the rare isotope that powers dreams of clean, endless fusion energy. Until this moment, helium-3 was mostly a theoretical resource, discussed in science fiction and fusion research labs. Now it was physically present, held in a grain of lunar rock for the world to study. Estimates suggest that just a small handful of this mineral could supply vast amounts of energy, a solution to Earth's growing energy crises, and a clean alternative to fossil fuels. But the implications go beyond energy. The differences in lunar geology suggested that the moon has recorded ancient cosmic events with far greater clarity than Earth. Its dormant nature, preserving secrets buried beneath countless layers of dust and rock. Scientists believe that further study of these samples could unlock answers about how the Earth-Moon system formed, and even about the broader history of our solar system. And if the moon holds such treasures just beneath its surface in a few kilograms of rock, the bigger question remains: what else might be hidden in the darker, more mysterious regions of this silent satellite? The moon is no longer just a backdrop to Earth's nights. It has become a living laboratory, a celestial vault promising revelations that could transform humanity's future in ways we are only beginning to comprehend. Not all discoveries were strictly scientific. Some captured the imagination of millions worldwide. While exploring the far side, U22 encountered a strange, shiny substance glistening in a crater. Photos spread like wildfire across the internet. Was it liquid water? Alien technology? Something unnatural? The truth was still fascinating. It was impact glass created when meteorites slammed into the moon with unimaginable force, melting soil into a glossy, otherworldly material. Then came the so-called Mystery Hut, an oddly shaped rock appearing on the horizon. For weeks, speculation grew. Was it a structure, evidence of the unexpected? As U22 got closer, the mystery dissolved. It was simply a boulder, coincidentally shaped like a cosmic rabbit. But these viral moments revealed something powerful. The moon still has the ability to ignite wonder and curiosity across the world. Even in the era of advanced science, every rock, every shadow, carries the potential to become legend. Perhaps the most moving experiment of all was not about minerals or craters, but about life itself. On Chang'e 4, Chinese scientists carried a tiny sealed biosphere. Inside it were cotton seeds, yeast, and even fruit fly eggs. Against all odds, in the harsh silence of the lunar surface, one of those seeds began to sprout. For the first time in human history, a living plant pushed its way into existence on another world. The plant did not survive long under the brutal conditions, but its symbolic meaning was undeniable. Life could begin to take hold beyond Earth. It was a brief, fragile glimpse of a future where astronauts might one day cultivate lunar soil, grow food in domes, and take the first steps toward a permanent cosmic home. It was no longer just science. It was a promise, a whisper that the moon might one day sustain us. Behind the science, a new question began to rise. Who will control the moon? By law, the United States is prohibited from cooperating directly with China in space projects. This has left the two superpowers advancing on separate and often opposing paths. NASA, together with SpaceX and international partners, pushes forward under the Artemis program, aiming to return crews to the lunar surface. Meanwhile, China is moving toward its own ambitious lunar presence, step by step, with the technology and infrastructure that are strikingly independent. The European Space Agency has collaborated with China on certain missions, signaling that alliances are beginning to shift. Other nations, from India to Russia, are also watching, some quietly deciding which way to lean. The stakes are vast. The reserves of frozen water at the moon's poles, which could be turned into rocket fuel and drinking water for future explorers, and the potential treasure of helium-3, fueling hopes of clean energy for centuries. The 1967 Outer Space Treaty forbids nations from claiming territory in space. But there is a loophole. It does not clearly forbid the extraction of lunar resources. This legal ambiguity, some fear, could ignite the next great resource race of human history. The moon, once a symbol of unity and wonder, is now quietly becoming the stage for a new geopolitical contest, one that might shape who leads in space for the next 100 years. China's ambitions do not stop with exploration. The roadmap ahead is bold and permanent. The next mission, Chang'e 6, aims to return fresh samples from the far side of the moon, pushing even deeper into unexplored terrain. Beyond that, Chang'e 7 and Chang'e 8 will focus on the lunar South Pole, a region cloaked in eternal shadows where water ice may lie hidden in craters. That ice is not just a scientific curiosity. It could be transformed into drinking water, breathable oxygen, and even rocket fuel. But the most audacious plan goes further: to construct a robotic base on the moon, built with 3D printed structures using lunar soil itself. A base that doesn't need shipments from Earth, but is grown from the moon's own dust and rock. Step by step, China is moving towards something revolutionary, not just visiting the moon, but settling it. And each mission brings us closer to the moment when the silent surface becomes a human frontier, alive with machines, laboratories, and perhaps, one day, voices. The moon is no longer a barren rock adrift in darkness. It is revealing itself as a vault of resources, of secrets, and perhaps of humanity's future. What China has already uncovered both inspires and unsettles, because it proves the moon holds far more than we ever imagined. The choices made in the coming years, about who explores it, who protects it, and who claims its treasures, may define the course of our civilization. And yet, this is only the beginning. What waits to be revealed beneath its shadows, beyond its craters, and deep within its frozen poles, could change everything we know about our place in the universe. If you thought this was the final chapter, you're mistaken, because the most extraordinary revelations are still to come.